Seth, can you hear me okay?
I can hear you loud and clear.
That big ball of fire up there. We don't see that a lot. That's the sun.
I've heard the legends.
Yeah.
All right.
Well, we're waiting for folks to log in. Let's see. This morning, I think it was minus 1 or 2 degrees Fahrenheit. So it's warmed up quite a bit. Actually, quite a bit. We're in the 20s. So a few degrees, minus a few degrees Celsius. Not bad.
We're having a heat wave, a tropical heat wave.
Yeah.
Hello. All right, we got our first
Hello.
comment. Hey, everybody, 62 people joined already. That's awesome.
Welcome, everybody. Hope you're all in some warmer place. Hey, Tim. Cyan, Jane. Hello. Hello, Bailey. Hello, Philip. Tim. New Brunswick. Wow. Marat. Nice to see you, Bailey. Great.
Oh, this is awesome.
And Jillian. Hello, hello. Thank you for joining. Renee, Michael.
1 degree in New Jersey.
Oh, really? You guys got us beat.
Wow.
It's 2 degrees warmer than we had. So that's still chilly for New Jersey. Hello, Scarlett. And Tim.
Shorts
Canada.
and t-shirt weather.
Awesome.
Yeah, exactly.
Sandra, 32 degrees in Georgia. Oh, that's chilly for Georgia.
Yeah. Around here where we say, oh, that's top button weather. That's
Yeah. Hello, Michael.
yeah.
Yeah, it's still colder than we are in Maine. Yeah. Well, it's not minus anything right now. It's like 20 something. It's not bad at all.
Awesome.
So I can get away with not wearing a hat. Oh, it's snowing in Georgia? Whoa. What is going to happen to the peaches and oranges? Not good.
Oh, we got a little feedback there.
18 degrees. And where's South A? SA. Is that South Africa? Must be South Africa. Oh, that's warm. That's probably 18 degrees Celsius too.
Yeah.
Not bad.
That's
All right. We'll give folks a few more minutes to pile through here. Mm-hmm. Yeah. Minus 49 degrees Celsius.
Oh, goodness.
Oh, wow. Yeah. Edmonton, they have us beaten by a long run.
Dear God.
Okay, I can't complain anymore.
Okay, Bailey, you win.
Yeah. It's a plane. I probably can't see it. If I can zoom in. No. All right. 13-3. Egypt. Oh, wow. That's still very pleasant. 13C. Not bad. Yeah, we don't, Jessica, we don't have much snow. I don't know what's happened. We just haven't gotten much this year so far. All right. Should we get it started, Seth? Giving folks a few minutes to drop in.
We just topped 90 participants.
All right, wonderful.
I think it's starting to slow down, but yeah, let's give it another minute.
Okay, no problem. Well, hope everybody's enjoying their Sunday, not working too hard and not out in the cold, especially up in Edmonton, Canada. It sounds really cold. Hey, Brooke.
Hey, Brooke.
That's Jessica, by the way. It's not my inner voice. I mean, it's, sorry, that's Jen. I just called Jen Jessica. Sorry, Jen. Hey, Dale. South Portland, 22 degrees. That's probably
muted.
No, you're not.
So, oh my God, so sorry. Now I am.
Okay.
Hi, everyone.
That's Jen from our team. Yes. Oh, Burbank, California. Rub it in. Not fair. Not fair. Nice. Excellent. 20 degrees, 21 degrees in Stellenbosch, South Africa. Athens, Greece. Oh, this is awesome. We're getting an incredible group of folks from all over the world. This is awesome. All right. Rockford, Maine. What? 100% rain. Oh, it better not be. Hey, Nick. This is great. All
Okay,
right.
we're at 98 people. If
Okay.
2 of you have a friend you can drag into this thing.
We'll get 100. We'll reach 100.
99.
It's crazy. There's snow in Georgia. That's nuts. Luke, hey, man. Luke Sandon's on the line. We'll actually have a short little video with him on it in just a few minutes here.
All right. Well, we're 5 minutes in,
Vegas.
so we should.
Oh, nice. Hey, Brian.
Wow. Yeah, we should probably jump into it. So,
Okay.
hi everybody, and thank you for joining us. I'm Seth. That's Sasha right there. And
Hey, guys.
Sasha, thank you for being out in the cold. Apparently, it's not quite as cold as in Edmonton, but thank you for being out there.
Yep. Sure. My pleasure. Yeah, I want to thank everybody. This is it's probably well overdue. But before we really get kicked in here, first of all, I'm for those who don't know, I'm Sasha Derry. I'm the CEO and founder of bluShift Aerospace. And for those who don't know, bluShift Aerospace, we are the company that is making an Earth-friendly way to access space. And here in just a few weeks, we should be seeing the first full-size Marvel engine test right next to me. Using our proprietary green fuel, totally non-toxic, near carbon neutral fuel. And actually right behind me, this is not a coincidence, but right behind me, if I can back up a little further and not slip on the ice. So you can see that the sun's kind of shining, but right to my side there, that is the part of the launch rail system we use for Stardust. And if you launch Limestone, Maine, a wonderful place. Yeah, hey, Pedro. And Pedro was there. Up in Limestone, Maine, at the former Loring Air Force Base up there on the far end, was the southern end of the runway, northern end of the runway. And unfortunately, due to overcast conditions, we never got quite above 50% or below 50% cloud cover. We couldn't launch that day. So it was delayed for about 2 more weeks, and we had our successful launch. So that is the launch rail system. And actually, as Seth, I think Seth, you were commenting what? You made a funny comment earlier today to me about that launch rail system.
Oh yes, I was reminiscing about driving up to Limestone. You were in the rocket truck with the trailer in tow, and I was behind, just making sure that everybody stayed, behind me, and that I was a fair ways behind you. And I was thinking, man, I grew up with launch pads that topped out at about 3 miles an hour when there was nothing on them. That was the fastest they ever went. You could walk faster than that, right? And
Yep.
and here we are doing 85 with a launch pad. And that was just an amazing experience for me.
Not too many launch pads move at 80 miles per hour or 75.
That's when it really sunk in, like, this is new space, man.
Yeah. I just want to point to this building back here. This actually was a building with a guard shack here on the base before. It's moved around. We've moved it now 2 times. But that was our original, actually it's our second solar panel array. We went from 1 solar panel up to 3. And now we have quite a bit more actually behind that over, let's see if I can point to it. Let's see. Here is we have a solar trailer system HOW that now powers our test stand and everything we're doing here. But we're still using those 3 panels up there and Schneider power system today, along with the kilovolt batteries in the low temperature conditions. It's pretty cool. So we're trying to do things as renewable and as sustainable as possible. So let's begin the tour. So I saw the launch rail system. We won't be reusing that one. We might be using parts of it. But let me bring you over to the test cell. And in the background, you'll see Gerard. Hey, Gerard. Actually, let me bring it a little tighter here. Not wear a mask, but Gerard is our. Will you introduce yourself, Gerard?
I'm the lead test engineer for bluShift. And yeah, I come from northern Maine.
Very-
Raised in Maine.
Very close to where we launch from, right?
Exactly.
Yeah. So now, actually, this whole you can't see it. I'm going to zoom way out by walking way out, and I'll come back. We'll come back to Gerard in just a second here. But I'm gonna just kind of give you guys a sort of a panoramic view of what's going on here. So where we just came from is the test cell.
Sasha, I'm just gonna cut in real quick. We're getting a little bit of lag, so if you could just move the camera a little bit slower, though. Yeah.
Sure.
Thanks.
Yeah. So you can see, I apologize for the lighting here. Cover up the sun. Let's see if I can get the sun's so low. Come on, sun. Just, there you go. Well, anyways, test cell there. We store our oxidizers in these rooms, and then we have our sort of a tool shop and other things back there. Over here, we have the wall, which is, in case anything unexpected comes out the fiery bit, we have something to absorb that. But Gerard is the one who spent a lot of time modeling this, and I just want to give him an opportunity to go over all the considerations he had to go through to design the full concrete test stand here. So we're back with Gerard. You talked about like kind of the things you worked on, what you had to take into consideration here with the concrete test stand that we built.
Yep. Well, we knew that we wanted to have something that was robust and reliable. So we're using high factors of safety for every component that needs it, and then our other goal is just to collect data like no other. We want a lot of load cell data. Of course, there's the main thrust load, but then there's also some lateral loads that we'll be looking at and tracking kind of how what our mass flow rate is, and then trying to compare all those variables, look at them all together, and see what that means for our engine performance.
And you had to, you guys, actually behind this wall is more concrete blocks to withstand the possible safety factor of thrust or otherwise, right?
The term we use, the belt and suspenders support. So we have our main steel structure that's holding the test engine. And then we also have a boatload of concrete, not just this wall, but behind this wall, that's also supporting in order to be able to receive that main thrust load.
Yeah. Can you tell people a little bit what you see, what we're seeing right here?
So we recently installed
We're losing Gerard, but when I first saw, oh, sorry.
Collar, and this is kind of just what the rocket engine will be pushing against. And we.
Whoops. Oh, hold on a second. Can you hear us now? We might be too much in the concrete. I lost it. All right.
Yeah, I think you're too far in the concrete.
Sorry
it was
about
a good. If the video had to freeze, it was a very good shot for it to freeze on. We got a good view of the collar. But yeah, Gerard, can you walk us through what its purpose is?
He's asking if you can walk through the purpose of the collar there.
Yeah. Okay, yeah, so that just receives the main thrust load of the rocket engine. And on the other side of the collar, in between the support and the collar, there's a load cell. We have to use a 50,000 pound load cell, which is just a huge piece of metal to receive the thrust load. And that's because we're expecting around 15 to 20,000 pounds. But to get a good resolution and to take care of any unexpected things, then we go to around a 50,000 pound load cell.
Very cool. All right,
So
thank you, Gerard. Yeah.
That load cell, the way I like to describe it to people is like when you were a kid running around the produce section of the grocery store, right? And there were those scales for how many pounds of onions you're buying or whatever. And sometimes when you're a kid, maybe you would push up on it and be like, hey, look, I'm buying, negative celery or whatever, right? That's basically what's going on in these load cells. It's a much more expensive, much more refined version of that, right?
Right. Yeah. Yep. Exactly. Yeah. It's what happens is when you apply a load, you deform a piece of metal. Then you look at the strain in that metal, and from that you can back out a load.
Right. Well, there are some other interesting forms of data collection here. All the sensors, which actually there's a brief video that will go into depth later on. But I noticed that some of these bricks are painted black. Is that for data collection as well?
Right. Yeah, we're gonna have a number of cameras set up, And what we found from previous tests is that it's not just, it's not just a temperature data and a load data that you're looking for. A lot of times when you want to see how it's performing, you need audio and visual data. So we'll be setting up a number of cameras and focusing on kind of right after the nozzle, what's going on with the plume, as well as further on down the line, what's going on with the plume. And that kind of tells us how the engine is performing. And the black walls help us see that even better.
Thanks, Jerome.
Yeah.
Hey, Sasha, for folks, some folks might not be too familiar with bluShift. We're testing here a hybrid.
Thank you, Jared.
engine.
Yes.
Can you
So
walk us through what that is?
Sure. A hybrid engine, for those who don't know, is it's where the fuel, everybody's familiar with liquid rocket engines, think Saturn V, solid rocket motors, think of, the boosters on the shuttle or your Estes rocket, right? So hybrid rockets are simply where the fuel is a solid, it's inside the combustion chamber, and the oxidizer is a liquid. Technically, you can have it the other way around too, but almost everybody does it that way. So there's some really nifty features to hybrid rockets. One is they tend to be just inherently a lot safer. Shout out for Estes. And they're much safer. It's very hard. Almost always the fuel is not explosive, and in our case, it's not only not explosive, it's completely non-toxic. And you typically have half the plumbing. You don't have to deal with the plumbing of your fuel, since your fuel is encasing your combustion chamber. So it really simplifies the testing, manufacturing, production of the rockets. But they tend to be sort of the underdog of the rocket world. They tend to be better performing than the solid rockets and lower performing than liquid fuel rockets. Our belief is we can actually get pretty close to some of the liquid fuel rockets in terms of performance, but we're not shooting for cutting. We believe by working with hybrid engines, we can kind of balance the cost and performance ratio such that we can economically and cost effectively ultimately launch tiny satellites to space. And do it in just do it in a very small payload size, around 100 kilograms. That's probably a little more than you wanted to say.
No. This is all good. So what we're seeing there, that metal structure, that's the cradle that's going to hold the reaction chamber. So it's a big metal tube. It's about 2 feet across.
Yep.
And that's where the solid fuel goes, right?
Yep. So what you're seeing here is a combustion chamber, and the fuel be inside there. That whole thing weighs, gosh, I think it was like over 4,000 pounds, is what that weighs, or that is in kilograms. Sorry. And for everybody who's not in the U.S., and then the oxidizer is actually contained in this room here, a climate-controlled room with we have a special system here, as you can tell. So,
can you get us a little closer there? I can't
a little zoom here.
Yet.
Yeah. This is sort of an internal joke. Maybe some of you guys will figure it out. I'm not gonna reveal there. Not that it's a really a secret, but it's a little inside joke for everybody to ponder what's going on there. So the oxidizer will be pumped in. Well, actually, not pumped in. It'll be pushed through into the combustion chamber, and our initial test here in a few weeks will be just a few seconds long. I think 5 or 10 seconds long. It's an outhouse.
Yeah, exactly.
I grew up with one of those. No, it's not an outhouse. So I guess you could do that a couple times. And then we're going to work up to doing engine tests that are burn for over. I think it's over 80 seconds long. That'll be our full burn time. And we're looking to do on the order of 12 to 24 tests. One thing I really wanted to say too is that this would not be possible without, I'm going to sound like public radio or something like that, without the funding support of, first of all, MTI, Maine Technology Institute, but especially our crowd equity funding folks. Hopefully many of those are on the call right today. We've been running a crowd equity funding campaign. We restarted back in November, and we're shooting for raising a full $1 million this year. And by the actually the next couple of weeks, we're shooting to raise the full 1 million. And when we hit the $1 million mark, we actually will kick off an additional $100,000 of funding from MTI that's non-dilutive funding. So again, if you haven't already, please consider becoming a future investor in bluShift by joining our crowd equity funding campaign. Thank you, Seth, for posting that link. And we're very excited. I think we have now over 1,000 investors of all ilks from all over the world. And people are just passionate about seeing the greening of aerospace and seeing bluShift lead the way here in the great state of Maine. Make sure I give everybody the perspective of what we're around here, but I think I've kind of covered that. What I want to see is give time for folks to ask questions that they might have. It's not too cold here, so I'm going to stay outside.
I've got a good one from I hope I pronounced this right, Ryo Iwamura. He said, how many years does it take? So Sasha, we actually have a video going into detail on the early years of the company coming out early next week.
Yep.
But the company itself was founded in 2014, but development kind of started a couple of years before that, right?
Well, yeah, it only started a year before that. It was 2013 when I discovered the fuel with an engineering friend of mine from the University of Maine system, and we tested here. We actually found the fuel on my brother, the source, the root source of the fuel, off of my brother's farm in North Yarmouth, Maine. And again, non-toxic, very close to carbon neutral, and not expensive. So hey, Mark, and yeah, it was only a year later that we formed the company, bluShift Aerospace, with a group of people who were working as volunteers for the company initially, working for equity in the company.
And this wasn't your first startup.
No.
You own a couple of businesses, and you've taken one from just an idea and not even a garage, right? You moved up into a garage to then be a $30 million company.
It's true. Yeah. So my first successful baby is Alti Store, renewable energy distribution retail company. Been around since 1999. Originally based out of Massachusetts. I grew up here in Maine, but lived in Massachusetts for a number of years. And the company is growing strong and continues to do so today. That company sells solar panels, inverters, many of the things we use right here at this test stand, in fact, no coincidence there. And so sort of doing things in a greener, more earth responsible way has always been in my blood for many years. And so it's I'm proud that we're sort of demonstrating the way that rocketry and space exploration can be done in a greener, more earth-friendly way. It's a very exciting time, and it's really neat to see that we're changing the dialogue on, even after our launch of Stardust, we started seeing articles in Space News and even on Forbes and also BBC about how why aren't other companies doing things in a more earth responsible way? And I think we've participated in changing the dialogue. I think the scrutiny is now on a lot of these rocket companies on doing things in a more earth friendly way. Seth, I just realized something. What folks are not seeing here is that you guys are all seeing a lot of concrete and steel and buildings and just, the stuff that's behind closed doors. But you're not seeing, there's a lot of work that's been going on here for a long time, and you're not seeing a lot of the folks that are working on it. But there's a heck of a lot of wiring and plumbing that's being done. And that's all being done over at the workshop back at Hangar 6. And we have a video where I interviewed with Luke Sandin, our senior mechanical engineer, on Friday. It was just that we actually missed Doug and Aaron, who've been doing the bulk of the plumbing and wiring, but really the whole team has been getting in on it to help out to push this forward. But they've been wiring and plumbing up something like over a half a dozen boxes, and these are gigantic enclosures to control and monitor these tests. And that's, if you don't mind, can we just roll up that interview with Luke and talking a little bit about one of the tests, one of the enclosures that was being worked on?
Absolutely. Yeah. All right. Can everyone see that?
Yes.
Excellent. Rolling the clip.
Guys, I'm here with Luke Sandin, our senior mechanical engineer. And I want to give you guys a little context of what these guys have been working on, and let Luke talk about it. But these are all the things that are going to go over to the test stand that you won't see until a few weeks from now. So Luke, can you give us a little overview of what the guys have been working on?
Yeah, sure. Well, right off the bat, I can't take credit for this actual hardware. This is one of our technicians, Doug's handiwork. But yeah, there's a lot of things that are in the shop, not at the test stand yet. So we're giving you a little sneak preview of that stuff here. These are a lot of our electrical boxes. There's 8 of these enclosures just packed full of terminal blocks and wiring and connections that all help us collect data from the engine and also control it and make sure it can shut down and start up properly and be safe, and so we can get all the data to get as much learning from every engine test as we can. So this is just one of 8, like I said, and this particular one has the actual computer that collects all the data, and you can see all the connectors on the side that are going to come from all of our sensors. We have dozens and dozens of all sorts of different sensors, pressure sensors, temperature sensors, and load cells for measuring thrust and the weight of tanks, and as well as actuators like valves. So we tell a valve to open or shut in these boxes, enable us to do that. So this is one of the big components that's not out of the stand yet, but is being built in the shop, and we'll test it in here, hook it up with cables, make sure it's working, and then we'll bring it all out, hopefully in the next couple of weeks.
Very cool. Immense amount of work. Thank you, Luke.
Yeah.
Wish we could have snagged the other guy team members, but I didn't snag them until it was the end of the week. Thank you, guys. See you soon. All right. Always a tough talking with a mask and having glasses. You think 2 years into code, I somehow have that figured out.
Yeah.
But I also want to say that the guys are working really hard on getting this all up and rolling. And this is actually our 5th test stand, believe it or not. We have spun up numerous ones. We've had one kind of come down where all the wiring melted and caught on fire. It was a minor thing, but this is by far our largest and most professionally done test stand. The guys have really taken this up a notch. And of course, the thrust levels on this engine are 10 times as powerful as what was on Stardust. So it's going to be really exciting to see what comes out of this. It's going to be one of the larger commercial hybrid rocket engines you'll see out there being used. And, not the largest, but one of the larger ones. We're really proud of what's going on here. And I'm really proud of what these guys have been working on. I also want to say that, it's really a neat thing here. Oh, sorry. I just want to say it's a really neat thing to be here on the Brunswick Landing, which is a former Brunswick Naval Air Station where the P-3 Orions, which were sub-hunters, used to take off from. In fact, where we're standing right here is what was called the Red Label area, where the P-3 Orions might have been loaded up with ordnance to go out and monitor the Soviet subs back in the day. And so, it was like 10 years ago when that base closed up, and the town really took a gut punch, as a lot of towns have when military areas get shut down. And it's incredible to see here the amount of really the town has really bounced back with the amount of businesses and innovation that's really going on here. And I'd like to think that bluShift's been a part of that. So it's really cool to be here. It still gives me chills to kind of come on the base. I remember when I was a kid, I lived in Brunswick for about a year and a half. And, this place was forbidden. You were not allowed to come on here. So it's really cool to be here still to this day. Shane was stationed here. Oh, very cool.
Wow.
That is cool. Nice. So I'm sorry, there's other questions. I want to make sure I give ample time for other people to ask questions.
So many. I just want to bring home real quick that For us, this is a big step up. This is a much larger engine than what flew in Stardust. And even it's pushing the upper limits of what's standard, in the industry for hybrid rockets. But the rockets themselves are going to be pretty small, really on the small side of things. Both Starless Rogue for suborbital and Red Dwarf for orbital. 100 kilograms for the suborbital payload. That's smaller than everybody out there right now, right?
It's smaller in terms of payload capacity.
Yes.
Yes, yeah. And that's the whole point. Is we're trying to create a truly dedicated launch option for this whole brand new, brand new, but this relatively new market of satellites called nano satellites or small sats. And it's a market that's expected to grow to be over $28 billion just to launch the satellites, not even the market to like make them, to develop them, do things like, Spire does or like Planet does in terms of making them, not even the services, but just the launching for these satellites is expected to be $28 billion over the next 10 years. That's really exciting, but nobody today is launching them, providing them with sort of the first class customer service that will be providing. Everybody, if you're a nano satellite, you basically have to ride piggyback or hobo or second class with a gigantic payload like you might on SpaceX. Now the costs are quite a bit less, but nobody's going to be able, there's no company out there today that's going to be able to provide them with just sort of dedicated service where you as a CubeSat customer it's basically your payload and your payload alone. You might have one or two other people or customer payloads coming along. So that's the market that we are going after here with 100 kilograms. Okay, right. Let's look at some other questions. I know there's a bunch coming through there. Yeah.
Keep them coming, guys. Bailey Ron asks, does investing provide the investor with shares, or is it more like a GoFundMe?
So it's a crowd equity funding platform, WeFunder, and it's a safe note is the vehicle that is used with that with WeFunder. And a safe note, what it basically provides you with is future equity in the company when we go through a priced round. A priced round would be, for instance, traditionally a Series A round. And in our case, we are planning to ramp up our seed round and raise. Well, between the crowd equity funding and the seed round, we're looking to raise about $8 million by the middle of this year. And then
Sasha, I'm losing you a little bit. Turn back.
After that, that would be okay behind the concrete. So we are planning to do the Series A round probably by the end of this year, or begin that round, or by the middle of the following year, next year. And that Series A round is when that safe note gets converted into stock shares in the company.
Another question of timeline from Jason Cutter. Where and when is the next launch? And thank you, Jason, for tuning into Stardust.
Yeah, thank you very much. Well, that's still being determined. As some of you folks might know, we are working with folks, the folks of both Jordansport and Beals, to see if there's a way in which we can launch from there. There's an island there that would work for both suborbital and orbital launches. But the towns have a lot of concern, and we're very much a different business for that town. So we are working on many different options in terms of where we're going to launch from. So it very well could be that where we launch from suborbitally is different from where we launch orbitally. So it's still up in the air, still being determined, but we will be launching one way or another by Q3, Q4 of this year.
Jonathan Moss asks, what is the current year you're targeting to be cash flow positive?
Thank you. Yeah, we are targeting 4 years from now to be cash flow positive. And that's assuming we're putting money and effort into going all the way to our orbital services, which is where we see the big growth in revenue. We could actually technically park it as a company just doing suborbital services, launch services. So we go up to space and come back down again with largely research-based payloads. However, there's a whole lot more growth to be had in the orbital launch services, the dedicated CubeSat launch services. And that's really where we're shooting for. And that, the Marvel engines we're developing that here today, the whole concept is that the same engine we use suborbitally, just one engine for the suborbital launch rocket, Starless Rogue, we'll be using multiple of those in parallel and in multiple stages, 2 stages for the Red Dwarf orbital CubeSat launch vehicle.
Tim Scammell asked, was NASA online for your last launch? I think there were a couple of NASA employees who tuned in out of interest. And I think that there was 1 or 2 guys from the NASA spaceflight channel that were in attendance. But I don't know if there was anyone like officially representing NASA at the stream.
Yeah, I don't know. I don't know if there's anybody. There certainly wasn't anybody officially representing the stream, but largely because we were doing it on the weekend, so anybody tuning in would have been doing it on their own time. So I do know there were several folks that were tuned in, and you know, some folks have been really helpful to us in terms of helping us develop our technology out at the Marshall Space Flight Center, it was really cool to hear that their support of what we were doing, and the fact, you know, we had our challenges, we had our weather challenges, we had a valve challenge, and overcoming those challenges was amazing. It was an amazing experience, and it was cool to be cheered on by folks who've really been helping us out technically at NASA. So it's really cool. NASA has been really a good resource for us to learn how to do hybrid rockets better.
Dominique Evans Bay asks, will you be explaining what is involved with CTE mission CubeSat launch? Dominique, if you can clarify what CTE is, I'm not familiar with that one. But you know, what altitude is let's talk Starless Rogue suborbital. What altitude will it reach? How long will it be up there? You know, what's the mission profile in general? Yeah, so thank you for asking that question. One of the fundamental thing that we're looking to differentiate ourselves on, and this is after doing something like 40 customer interviews, and half of those were for said the biggest pain point when going suborbital, this is largely for research-based payloads, but was the short period of time that they were able to go up in space. You know, they're spending maybe 1, 2, 3 minutes in 0G. So what we're going to do to differentiate ourselves, and what we've been planning since the beginning of the design of Starless Rogue, is to reach 6 to 8 minutes of 0G. That means no gravity, exposure to space. And what we found from our potential customers was that's a real game changer for them. You know, they're spending all this money, all this time, and to double the time in which they can do their experiments in space until it's brought back down to Earth was amazing. It seems simple, it seems basic, but it's a real game changer versus what's available to them right now from whether it's Blue Origin or Virgin Galactic or others. So we're really excited to be able to provide that differentiator. Absolutely. Oh, and someone earlier on asked for an example of another company using a hybrid rocket engine, and Virgin Galactic is one of them. That's right. Their fuel is something that's sort of akin to rubber, I believe. Yeah. Yeah. And I believe the thrust levels on their engine is larger than the Marble is. I can't remember how much more, but yeah. Oh, Christian Bradley Hubbs asks, in the future, will all of your flight hardware engines go through a testing phase and static fires before being used for launch? So this is when we hit production, I'm assuming. Will we be testing every engine as it rolls off of the line? That's a really good question that I don't have an answer for just yet at this time. Right now, we're really trying to tune up this engine and get it working right. And for us, what that means in terms of developing the full-size Marvel engine and making it work right, what that means is it reaches the thrust levels we expect. We dial in the oxygen to fuel ratio just right, the oxidizer to fuel ratio, and the stability. You know, my hope is there's a point where we can develop the engine and feel really confident about its performance when it comes off the production line, and we're going to be reusing our engines. And I'm for sure the engines will be going through, and their components, the subsystems, are going through a series of tests. Whether we will take the whole engine and retest it on the test stand, I'm not sure yet. Good question. And even more technical, he follows up. Does one of the propellants being solid, with the solid fuel, does it significantly make refurbishment easier or harder compared to if you were using a liquid fuel?
I can't say I know because I don't know. I'm not as familiar with liquid fuel rocket engines. For us, it means pulling out. It means taking the engine off, the bulkhead off, and removing the solid fuel core. So, well, it's certainly heavy and awkward. It's not logistically too difficult for us to pull it off. So I'm not sure if one's more difficult than the other.
And it probably helps that we're dealing with a pressure fed system and there's no turbo pumps.
Yeah, that certainly has helped, besides lowering the costs, it really lowers the complexity for our engines as well.
Yeah, and it really is something to see preparing for a new test. It's really just the old fuel core comes out, the new one goes. Well, it's not by hand anymore. Now there's a crane. Now actually there's going to be two cranes in parallel there.
Yep.
But yeah, it's a pretty straightforward process. Yeah. Okay. Ooh, I don't know to what extent we can answer this one. This is going from Addison. Sorry, last name got cut off there. Addison, can you share any information on your software and DCS architecture?
So we're using some National Instruments data collection system, and we are working with an outside around it, some customized hardware and software around that. Which is, it's really an extension of what we did for Stardust and the last version of Marvel, the sort of the prototype version. I should have asked the engineering team, but we've really increased the number of sensors and actuators and control versus the previous hone in on the performance. And to do that, we had to seriously step up the way we're using the National Instruments software and hardware. So I'm not sure that's a level of detail that he was hoping for, but that's kind of where it's at.
That's what we can do. We're definitely a little bit over time. I'm good to keep going if everyone else is good to keep going.
Yeah, and I haven't lost my ears, so keep going. Yeah.
All right. Well, Rio Iwamura commented, I thought that the bricks do nothing. That is very much the goal. We want all force, no work.
Yeah, that's true.
That's what we're going for.
Yeah. These are high performing bricks or concrete blocks. Yeah. Yeah. In fact, probably, I don't know, I'm going to guess about 50% of our blocks here are recycled and reused from our previous vertical test stand. So brought from one side of the base or the former base over to this side, and then we added to it.
Yes. I affectionately think of it as space henge. All right. Tim said thought we were closer to Holton. Sorry, no, Brunswick. We're still a fair ways from Holton, but Holton does have a special place in our hearts because it is the home of the Stardust Motel.
That is true. That's right.
Which we have only driven by, but took as a good sign.
Yeah.
Okay. Oh, Jason Carneal says, when's the next big engine test? We will have an announcement about that soon. We're really looking at a couple of weeks. And we will tell you. Basically, the plan is once we have high confidence that we are 14 days out from a test, that's when we announce.
Yep. Yeah, it's been tough. It sort of mimics what we did with Stardust, where we originally planned to launch Stardust in the fall in October, and we ultimately ended up launching on January 31st. And here we are. We were originally planning to do this engine test in October, and here we are in January. And there is actually a decent chance we might do it on January 31st. We'll see. We'll see what happens here. But we'll let folks know. We're excited.
We've got a couple questions that I would composite together as roughly, where was the last launch? And that was Loring Commerce Center. So we talk a little bit about the Commerce Center and the Air Force Base that was there, and why we probably are not going back for future flights, at least as a launch site. Yeah,
so Loring, first of all, the folks up in Loring and Limestone, Maine were awesome. They were wonderful, really supportive of what we're doing. And the area up there is, they've got incredible facilities up there. We were able, we restored the launch rail and Stardust itself inside the same place. It was what was the place called? The Hot Shot hangar where the F-15s. Sorry, I should know which ones were parked in case there was a Russian incursion. They could just jettison off and confront that. But it's an incredible place. Really supportive, looking for new business. Just like Brunswick Naval Air Station, all these facilities, all this infrastructure, really appropriate for big and small companies alike, and innovative startups like bluShift. So we enjoyed working with them, and ultimately even in the dead of winter. We really had to stay underneath 1 mile of altitude because of the possible places we could come down. So even though it's not very populated up there, it was populated enough that we really couldn't go beyond a mile up because of what's referred to as dispersion characteristics, where we might possibly land planned or unplanned. So that said, that's the northern reaches of Maine, and I have to say that I can't rule out the northern reaches of Maine being a possibility for suborbital launches. And I know Volt Enterprises, another Maine rocket company, air-breathing rocket, is operating up in that region, the neck of the woods. So I would say that it's not 100% off the realm of possibility, at least for suborbital launch.
Absolutely. All right. Here's another technical one from this is Addison Bacher. Got the full last name now. Can you share the target chamber pressures and thrust loads? We can definitely do thrust loads for Marvel 2.0 here.
Yeah. The peak thrust load is about 20,000 pounds. The chamber pressure, I don't have the top of my head. The guys have all, smartly converted themselves mentally to pascals, and I'm still stuck in PSI. I know it's a few hundred PSI, but I can't remember exactly how many PSI off the top of my head.
All right. Shane Sowers asked, can an engineering student volunteer with bluShift? We have a careers page on the website. I'll link that as Sasha's answering the next question. And then once we've got your information on file, that'll help us, when it comes time for another round of considering applications. But hey, don't be a stranger. Reach out, shoot me an email on the contact page on the website. I'll link that too, and we can just kind of stay in touch. Dominique Evans. Oh yes. CTE is career technical education. Okay, thank you for setting me straight on that. And yes, it would be particularly for suborbital. There might be people that are primarily doing the mission as a way to develop skills, as opposed to being pure academic research. But yeah, I hope that answers the question. All right. Sorry, just scrolling on down here. Sasha, can you comment on extreme weather and how it affects engine performance, particularly cold weather?
Yeah, and today, again, we have folks from Edmonton, Canada, so nothing to complain about here. Yeah, so we're really, we really tested the low temperature side of things when we launched Stardust. I remember the morning we woke up for launching Stardust, it was minus 14 degrees Fahrenheit. And, we had our, like I mentioned, we had the launch trailer and the rocket parked in a hangar that was definitely unheated. And it cycled through, probably went up to the 20s down to minus 14 degrees at least. So no ill effects came from that. We certainly had an issue with weather in terms of, for that particular launch, cloud cover. Cloud cover can certainly interfere with a rocket launch, but the cold temperatures did not. So it's a pain. It's not fun, but the guys literally, everybody, the team weathered through it, the whole team.
Yeah. Stardust was just
happened. Yeah.
At launch readiness, basically, for 2 weeks in those conditions, no problem.
Yep.
And someone after the first test, which this is the 1 year anniversary of, right?
That's
or
right. Yeah.
yeah,
2 weeks from now. Oh, the very first test, right? The failed test.
yeah.
Where we,
yeah,
because
sorry,
of weather, we
I
had to
shouldn't say
clear
test. I
of
should
it.
say
Not
launch
test, but
attempts.
launch. Yeah,
Yeah.
launch attempts. Thank you.
But yeah, we got this lovely email from a gentleman who I believe later invested, and he said, "Oh, don't worry. I know it's frustrating to scrub, but I've been at a launch where my payload was going to launch, and they had to scrub the launch 14 times for
Oh,
weather,
geez.
that rocket, which made me feel better and worse at the same time."
Yeah.
All right.
True.
Oh, Cyan or Shane Flad asked, where will we be able to access this recording? So if you've registered, you can go back to that page after the conclusion of this webinar to rewatch. I'm also going to upload it to YouTube early in the week, so it will just be publicly available from there on out. Okay. There was a good question here about, oh yeah, okay, Philip Rue said, how much control do you have over shutdown with the hybrid engine? And the power phrase here is fail to safe.
Yes. Yeah. Exactly. Yeah. So that was something we designed in Stardust too. That there really has to be an active on condition for it to be functioning, and that'll be true for the going forward. There will be a flight termination system on board Stardust, and there may be an automatic flight termination system on board our red dwarf vehicle when we get to that point. So the beauty of the hybrid rocket engines, and this is not just our hybrid rocket engine, but I would say others too, is that the moment you shut down the oxidizer, and even if the oxidizer canister was to open up, it just doesn't explode. Like the fuel and the oxidizer is not combined to explode. The fuel being a solid is unlike a solid rocket booster, but it's like wood blowing up. Wood does not blow up, or not easily. And the same thing is true for our fuel. It's very difficult for it to it has 0 TNT value, and the same thing for our oxidizer. So yeah, so the point is, yeah, it fails to safe.
Excellent. And this actually ties in perfectly to our next question from Denise Ventura, who asked, how is the approval process going for your future launch? I remember there were a lot of requirements around the flight termination system in particular. And so how's that going, and how's it going in general?
Yeah, so we've been very fortunate that we have a really good, solid liaison within the FAA who we've been conversing with. She's been a wonderful resource for us to go back and forth. And David, our CTO, David Hayrikian, has really delved hard into the regulations around launch, both suborbital and orbital. And so we are in conversations. We were engaging with another contractor to help us out with the dispersion characteristics for our launch vehicles, and in pursuit of getting the approval with the FAA. It's a long process, and while the site still has not been determined, that we're making a lot of movements forward now that can be done. That's appropriate for whatever site we ultimately launch from. But very quickly, very soon here in a couple of months, we really need to know exactly which site we're launching from to hit the time frame that we're looking for of launching by the end of the year. So it's going well. There's a lot of work to be done, and we've got a lot of capable people, both internally and externally, that are helping us out with that. Did I lose you, Seth?
I can't believe I did that.
Okay.
Sorry about that. Dominique Evans asked, is the payload retrieved after a suborbital launch? In ideal conditions, of course.
I'm sorry, can you repeat that question? Sorry.
Yeah, is the payload retrieved after a suborbital launch?
Yes, entirely. That's the idea, is to retrieve it and bring it back as quickly as possible to our suborbital customers. Well, some of them won't need it back. The intention is to always bring it back to our customers. And we will be providing a data feed. We're working with another contractor here in the beautiful state of Maine to develop a very high bandwidth connection with our rocket all the way to apogee. so that we can not only provide cool things like a video feed, but a downlink for our customers to send data down, instantaneous data, but also to, just in case the payload perishes, they will at least have their data in their hands before it does so. And Bailey put in will the plume affect the data feed? It certainly will. That's why it's really important for us to have, we will have 3 downlink stations downrange from the launch point, so that we can be communicating with the rocket, not directly behind the plume. So very good question. I just saw that pop up. Yeah.
Sasha, just behind you here, in basically a straight line, we've got the viewing area. The high-level investors can be out there and watch these engine tests.
Yeah, let's see that white dot over there. Let's see. Am I pointing to it on the?
Yep.
Okay.
Yep.
Yeah.
Just about there.
Yeah. That's where raw sewers
Oh God.
used to get put in there and fermented to convert it into to electricity. But now I think they're using it for other purposes. Yeah.
I've toured the viewing area several times. It smells like grass. It's fine. It's fine. It's fine. You wouldn't even know. Okay. Brian Harlan asked, is there somewhere we can see non-confidential vehicle and engine specs? Yes, I am now linking in the section of our website that deals with the rockets. You can see the breakdown on the 3 different rockets. Stardust has the most detail because its design is finalized, of course. Okay, let's see. Shane or Cyan Vlad said, could an actuary looking for ways to use their skills outside of finance apply? Don't see why not. I'll link that careers page again, and just send us your deets. Okay, where can one buy bluShift merch? Good question.
Yeah, we just we're very proud of ourselves. I know the team actually was asking for this. There might be folks out there too who are asking for hoodies. But now I think you scroll all the way to the bottom of the bluShift website. There is a merch link at the very bottom, and t-shirt. I'm wearing one underneath all my clothes here, but I'm wearing a t-shirt, bluShift t-shirt right now. There's some funny ones there too that the original test engineer Brooke made himself or designed with the fresh main rocket logo. Pretty funny. But there's a whole bunch of options there.
And thank you, Bob Reichman, for that question. All right. Oh, Dale Robin Goodman asks, is there a good story to be told about the bluShift moniker? Why not some
hey,
other
Dale.
color?
Yeah, shout out to Dale. Howdy. Yeah, so the bluShift comes from, if anybody's familiar with Redshift, bluShift is the opposite of that. So in the world of Doppler sound, when an object's approaching you, the pitch goes up, boop, and then when it goes past you, boop, it goes down. So if something's going away from you, the same thing happens with the light spectrum. If the object's moving away from you, which it turns out most of the universe is, it's called redshifting. If an object is approaching you, the light from it gets bluer, and it's called bluShift. So if it's moving away from you, it looks a little redder than it should be. If it's moving towards you, it should be bluer. Now, of course, these are at really fast speeds. So we like to say at bluShift, we're moving towards the stars, hence the name bluShift.
All right. It kills me to do this, but we're pushing on an hour, so we should probably do a couple more questions and then wrap up. But there's a good one from Brian Harlan about reusability. So the suborbital rocket, that's going to be fully reusable on a nominal flight. But for the orbital class of vehicles, what's the reusability look like there?
Yeah, at a macro scale level, we're looking to recover the entire first stage, of which there will be 7 engines. And with the new design, it's looking like there's 7 engines and on the first stage and 1 engine on the second stage with the current design. So we are looking to recover all of those. Now, of course, there will always be some level of component failure, and things need to be changed out and tested before we swap them out. So we're ultimately trying to be really conservative and saying, well, with things perishing, things not going right, we will shoot for just above 50% on recoverability. Now, of course, we aspire to do much more than that. And you can tell we have the ability to, theoretically, we should be able to achieve superior to 50% recoverability. But that's kind of what we're planning for internally.
Understood. And tying into that, Christian Hubbs asked, when you have both suborbital and orbital launches going on, will the recovery process for suborbital rocket and payload be similar to recovery for the first stage of the orbital rocket?
Yes. The short answer is yes. Yeah, just bigger.
Right, because with Red Dwarf,
but also ocean-based. Yeah.
Mm-hmm. Yeah, because with Red Dwarf first stage, you're basically recovering 7
Marvel engines
at once. Yeah, so it'd be bigger, but same basic idea, and it should be achievable with for Starless Rogue. Actually, we think we can do it with just an open stern lobster boat, and then for
yeah, that's right. Yeah, we believe that it should be quite feasible to bring back both the payload section and the Marvel engine section with a commercial lobster boat or fishing boat. So we're hoping to contract out folks who work the oceans to help us secure the area and also recover the rockets during launch. So yeah.
And then for the first stage, a dragger boat or some sort of a boat with a crane, but still nothing crazy.
Yep.
Yeah. All right. I think we've just about reached the end of the question. Oh, one more. Can this be similar to Pegasus? Kevin Smith. You're referring to the air launch, right? It's like 737, kind of an underslung, smaller rocket, and that goes all the way up to orbit, right? Horizontal. Correct. Yes, nailed it. Okay, so could we do something similar to Pegasus or similar to Virgin Orbit, where we basically get rid of the first stage and just use an airplane for that?
Yeah, so no, we're planning to kind of keep it simple and just stick with Marvel engines as our source of first stage. So we're not looking to strap it underneath a plane. It's not the realm we're going after right now.
Yeah, I guess that would actually pretty significantly increase the carbon footprint of the launch, wouldn't it?
It would, and it would also, increases the complexity. I think it's a really good thing on a theoretical level to think about your first stage being something that's commercially used regularly, but you look at the expense and the complexity, logistics complexity. For us, it's not something that we're trying to keep the cost of this as low as possible, so we can provide a dedicated launch option for CubeSats and for orbital customers that's also cost effective. And so there was like sort of the cool sciencey stuff, and strapping to underneath a plane is definitely very cool, and it has its use and applications. It's just not something we're pursuing.
All right. Well, that's all the questions that are in the chat. So thank you, everybody. These were really good questions.
Yeah.
And imparting, yeah, sorry.
Oh yeah, no, I just wanted to thank everybody very much for attending and bearing with us. Well, I guess you don't have to bear with the cold, but joining us here and seeing what we're doing. And again, a big shout out of appreciation to our investors on WeFunder and to MTI and others, and the future folks who are interested in investing in bluShift. What you see here today and what you will see in upcoming weeks as we push to a test wouldn't be possible without you guys. So thank you all very, very, very much, and keep the questions coming. We look forward to future webinars with you guys.
Absolutely. And we are in the race to 1 million. We want to see if we can cross that threshold by the anniversary of Stardust launch.
And get that bonus $100,000 for reaching 1 million from MTI. So thank you. Take care, everybody. Have a wonderful day and stay warm.